Hi and welcome back to another episode in the prolonged saga of the FRG-7700. Cleared the bench down a bit and over that way, if you can see it there, we have my new 100 meg scope. Because the frequencies coming out of the PLL board on this one are sort of around 40 to 70 megahertz, so it was impossible to see on my old scope because that's only 50 meg bandwidth, and it was really struggling up the top of its bandwidth. So I've got another scope. I've also got my frequency counter there. So what we're going to be looking at today is the output from the PLL board down into the main board, which is jumper J09 on here. So what I've done, I've got my scope probe and my frequency counter connected to these two connections. If you can see on the circuit diagram, see if I can get you in on this a minute. So where are we? So this is the output from all the VCOs going along here. So I'm testing between pins 1 and 2. I've got the scope probe and the frequency counter on pin 2, and I'm grounded with my scope on pin 1, but I've got the earth of the frequency counter on the chassis, which is the same thing. So yeah, we're going to be looking at the frequency and the amplitude of the signal coming off at this point. Something that Greg suggested doing, so I thought if I did a quick video on it, then hopefully he can watch along and make any comments. Now, the VCO that was in question was VCO number 3, and that's the 13 to the 20 megahertz band VCO, and I'm looking for 61.055 to 69.055 on that band. So really that's the band that we're looking at in detail, but just thought I'd share it and see what you think. So let's just get you up to the scope, and hopefully you can see that. There we go. So I'm going to pop the radio on. Okay, hopefully you can see both of those. Let me just have a quick look. Should be in focus. Fingers crossed. Anyway, yeah, let's power the set on. There you can see the frequency on screen coming at that test point, and we're on 0 megahertz. So let's pop on up to 13 megahertz, and that should be somewhere around about 61.055 or 61.052. I mean, that's not the best frequency counter in the world, but it is correct. Not far off anyway. So 13. So it's basically 13 to 20 megahertz. This VCO. 14. 15. Now this is the troublesome band. 16. So there you go, it's jumped to 17.052 there now, and the frequency's wrong. Let's try 17, which is exactly the same, no change in frequency between either of those bands, 65.110. Let's let it settle for a minute and see if it changes the reader, which it should do. So it's still reading high. I'm on 17 megs at the moment, it's reading 17.060. So it's still reading 17.060. Seems to be incorrect until it warms up a little bit. And for some reason it there you go, we're back on 17 now where we should be, and you can see the frequency counter's dropped to incorrectly 65.052. I wasn't looking at it at the time, but hopefully the camera caught the difference in frequency there. Probably slight, but So let's go through this band then right up to 20 megahertz, so 17, 18, 19, 20. So that's the limit of that band. So let's go back through it again. So 19, 18, 17, which is reading correct now, 16, 15. So it's jumping a megahertz. It's altering 1 meg at a time, and now we're on the other VCO. Now we've just jumped back to 12 megahertz, which is VCO 2, I believe. Let me just double check that. Yeah, so VCO 2 is 6 to 12 megahertz bands, so that should be 61055, which it is. Let's go again 13, which is VCO 3, back to 12. So you see there's a sort of jump between the two bands there. Sort of momentarily jumps to a higher frequency and then settles down to 12. There's not much of a difference in amplitude between 12 and 13 megs. I think that's what Greg was looking at, really, was just to see the difference. Hopefully you can see that trace. Yeah, you can. Brilliant. So let's go down. So 12, 11, and this one's down to 6. So 10, 9, 8, 7, 6. You see the amplitude is certainly narrowing down there. The intensity's up about as far as it'll go. So that's a VCO2. So if we drop down now to 5 megs, that'll be VCO1. Oh, now it's doing some strange thing now. It hung about then. So switching from 6 megabytes down to 5, it's jumped to 645 initially. You can see there's a slight delay there before the scope, or before the frequency settles. Yeah, strange goings on. So going down through 5, 4, 3, 2, 1 megahertz, 0 megahertz. So let's go back up through VCO3, which was originally our problem, but I think it's something to do with diodes, but we'll look at that in a minute. So 13, 14, 15, 16, so that's gone haywire again. So if you look, that's 15, which is correct. So this should read 64052 next, but it's reading 65119 momentarily. See how long that takes to settle. It's struggling to lock itself, isn't it? Somewhere along there. Still not settled. Come on. Still not settled. Let's wait for it to revert back to normal. Doesn't seem to want to lock at all now. There it goes. The 64052, which it should have been, so it's obviously jumped up. So 17, 18, 19, 20. So that's all of VCO3. So VCO4 then takes over at 21 megahertz. So there we are on 21, 22, 23. Let's say we're up in 70 megs coming out of this one now. We're going into the main board. 24, 25, 26, 27, 28, and the last one is 29. So yeah, it seems that the amplitude is right. It's going through. Yes, it seems like the amplitude is altering correctly. can certainly see a waveform. It just goes a bit random. So yeah, so 15 is okay. So 15 is there. 16. So 63052 on 15, which is correct. So 16 should be 64052, and it's jumped to megahertz or megahertz again until it settles. Then it goes back 64052. Strange. There you are. Anyway, that's that bit done.